Did we finish going through number 9 on page 23?
Yeah.
We did? Okay, I just want to point out, we went through a power rule using implicit. We found the derivative, we set the numerator equal to 0, we set the denominator equal to 0. And after that, you have to look at your instructions here because in this case, it's asking for points. So that means you're going to take your whatever x or y value back into the original equation and find the appropriate order pairs. And so that's why for horizontal tangents, we have 1, 0, and 1, -4. And for vertical tangents, we have 0, -2, and 2, -2. But if the problem says provide the horizontal tangent lines, the actual line equations, then the tangent lines need to be in terms of y. So I need to look at the y values and say, in this case, y equals 0 and y equals -4. If I'm asking for vertical tangent lines, they will have to be x equals 0 and x equals 2. Does that make sense? So let's say the graph looks something like this, right? 0 and 1, -4 are the horizontal tangents. And then 0, -2, and 2, -2 are the vertical tangents. So maybe the graph looks something like this. And you can tell that there are horizontal tangents here and here. So these will be the locations where the horizontal tangents are occurring, but the actual horizontal tangent lines will be y equals 0 and y is equal to -4. Meanwhile, your vertical tangent location-wise is 0, -2, and 2, -2. But the actual equations for those vertical lines will be x equals 0 and x equals 2. So the way you get your data is the same, but the way you present it is different, depending on if I'm asking for the order pair or if I'm asking for the actual lines through those points. Does that make sense? Okay, so today we're just going to see if we can work through 27. And then I'm going to save page 30 to 32 for you guys to work through tonight as a way of a final test review for tomorrow, or you can have me wait for me to walk through it with you tomorrow morning, 7:15. Health sessions, I have health session today, advisement, and with lunch, but also after school preparation. And this is really for anyone who needs me to go over their quiz or has questions about the quiz that you're unsure about, or you can come and ask questions about anything in the review that we've done. So I just want to provide availability today for tomorrow morning. Tomorrow morning is 7:15, and I'll go over page 32 for tomorrow's self session. And then you can use your calculator on your test tomorrow. Okay. All right, let's go to page 24.
You could possible if you could send out like a reminder so we can bring a calculator.
Yeah, I'll do that. Okay, so page 24, given x squared y plus y squared equals 2x, sorry, 2x, find dy dx. What do we need to apply here to find the derivative? Implicit and product, power rule and product rule, right? The x squared y, anytime you have variables multiplied together, you have to go through product rule to find the derivative. Okay, so go ahead and try that. And if you're working ahead of me, you can always look at the key to check your progress.
Okay, f prime g plus f g prime. We see two y variables. We're expecting two dy dx's to pop up. Y squared becomes 2y dy dx, 2x becomes 2. Now you're just trying to collect your dy dx terms together on the same side so that you can factor it out. And then once you solve for dy dx, careful, I think sometimes students want to cancel things out with implicit, but typically you're not going to be able to cancel stuff out unless you can somehow factor the same thing out of the numerator and denominator to reduce. But I think I see a lot of students try to start to cancel stuff out, and that end up losing points when they could have just left it alone. So leave your derivative alone unless you have good reason to reduce or cancel out. So most of the time, your implicit is going to end up with terms added and subtracted, numerator and denominator, and that's going to prevent you from reducing much. Any questions with part A? Yeah.
Why does x squared have a UIDX?
Because within product rule, we're asking for y's derivative. So here, x squared is coming from f, but then g prime is y's derivative, which is 1 dy dx.
Oh.
Yeah, good. So it's only showing up because within the context of product rule, something is asking for a derivative of y variable. Okay, any questions with part A? Okay, part B, find a point where there is a horizontal tangent. So where do we look for horizontal tangent? Set the numerator equal to 0. Okay. So this one, we can only go so far because if we set the numerator equal to 0, we're still left with two variables that are unknown, and we're not able to solve for it. On the test, I'll make it so that there's only one variable in the numerator, so you can solve for that variable, plug it back into the original equation, and then find that order pair. This one, you kind of have to guess and check, but I won't do that for the test. So on the test, there's only going to be one variable in the numerator. You set that equal to 0. You find that location. You plug it back into the original equation to get your full ordered pair. But the important thing is knowing where to look for your horizontal versus vertical tangents. And then for part C, find the points where there's a vertical tangent. Where would you look? Denominator. So you set the denominator equal to 0, and then whatever variable you find, you solve for, you plug it back into the original to get the other variable. But in this case, there are two variables here, so it's kind of hard to find. But yeah, the important thing is that you know where to look, and then after that, you're just solving for your x and y. Sorry, this one, there's two variables here, so we kind of have to guess and check, but you won't have to do that on the test.
Oh, we will.
On the test, it'll be, yeah, page 30 and 32. Those are better examples of what better representation of where you're going to see. But the numerator will just be one variable. It's not. It'll be just one variable, so it'll be easy to solve. Okay, let's look at number 2. Number 2 says find d2y over dx2. What does that notation mean? Second derivatives, okay. But let's focus on finding dy dx first. So look at number 2. Look at how that's set up. If I want to find the derivative, what process would you go through? Okay, so try that. See if you can find your derivative using quotient rule, and then we can worry about second derivative a little bit later. Oh yeah, sorry, you don't have a problem. Careful when you build your derivative using quotient rule, you don't forget about your denominator squared. More than a few students have left out the denominator when they're doing quotient rule, and that throws off their answer. So make sure you're remembering the full formula for quotient rule. Okay, so are we okay with the halfway point here? This is dy dx. Okay. All right, so to find the second derivative, what would you want to involve? Chain rule. You could go through quotient and chain, but we talked about how we usually want to avoid quotient rule. Sorry, we can usually want to avoid quotient rule if possible. And one way to tell is if your numerator or denominator, if they're not both variables, if one side is a constant, we should be able to just move it in a way where all we need is at most chain rule. So in this case, if we bring that 3 minus x squared up, then it just becomes a much easier to manage problem. We can just go through chain rule rather than having to go through quotient and chain. We'll get the same answer either way. It's just a little bit messier with quotient rule. Okay, so this is chain rule, right? We definitely cannot distribute that -2 through. This is stuck in this form, so we have to spell out our outside inside parts and build the derivative that way. So try that, see if you can build your derivative using chain rule. So once I get my second derivative, I'm just trying to do a little bit of cleanup, trying to push that negative exponent back down to the denominator. So here's my y double prime, or my d2y over dx2. Any questions with 2? All right, number 3, we have find the derivative for parentheses 3x plus 1 all over 1 minus x squared, all raised to the third power. What's involved here? We want to find the derivative. Quotient and chain. Okay, which one comes first? Chain. The way again, the way that we tell which rule comes first. Look at the parentheses. If your parentheses is over everything, then chain rule comes first, and the other rule comes second. If parentheses is only over a portion of the problem, then the other rule comes first, and the chain comes second. So identify your outside, inside. outside derivative, 3 parentheses squared. And then we can focus on the second part, which is building that derivative using quotient rule.
Which are we using quotient rule?
Because what's inside the parentheses has numerator denominator set up, so this derivative would require quotient rule. Because we have that fractional expression forces us into quotient rule. So outside derivative is power rule, inside derivative is quotient rule, f prime g minus f g prime all over g squared. And really, the major cleanup that needs to be done is just with what I highlighted here. You're just really cleaning this up. After that, after this, we'll just try to push it all into one fraction. But algebraically, that's really what takes the most effort. So we'll distribute the 3 through, distribute the 2x through. And then my cleaned up numerator of that expression is just 3x squared plus 2x. So, okay. Any questions so far? Right, now as far as putting it all into one fraction, let's just put all the numerator terms together and then put it together. So numerator is 3. It includes the 3x plus 1. How many of these do we have? 2, yeah, squared, and then we'll have 2x plus 3, that's the numerator as well. What goes in the denominator? Okay, how many 1 minus x squared do we have? It looks like 3, but it's actually what? 4, right? I know it looks like it's 1 here, but you see that there's a 2 here. That x is impacting that 1 minus x squared. So 2 of these, we add those together, we get 4.
Three go to the whole thing or just that?
Oh, just numerator, yeah. Imagine this is 3 over 1.
How many points would you take off if we like left it in the that yeah.
Yeah, I'm gonna ask you to simplify, so
This 3x squared plus 2x plus 3, like, and then multiply it by the 3x plus 1 over the 1x, or 1 minus.
let me square see.
Very fast. So
Yeah, I would maybe like 1 or 2 points.
yes.
You can just push together.
Yes.
Technically, you have the answer. I'm gonna ask you to simplify. Right?
Thank you.
If we were to distribute the 3 before we combined the denominators, yeah, if we were to distribute it to the 3x squared.
3 into
3
here.
into that and then.
That's fine, but typically we like to leave everything in bracket form. So this is the better form, but if you distribute through, I won't take much.
No, so- I don't even know yet. No, I'm getting like yes.
Okay, page 26. Right, number 1, you're having to build a derivative in function notation, and then after you build the derivative, then you can replace all your t's with 1, and then you're using the graph to help pull either the y value or the derivative. So number 1, what rule do we need to use?
to find the derivative. Or compare 1 and 2. What's the difference between the two of them? Okay, one is chain, the other is product. How can we tell?
The first one is
Chain. The first one's chain. Yeah, there's only one t, so it's function within a function versus product rule. If you have two t, that means they're separate functions, they're outside each other. This is two separate functions multiplied together. This is a function within a function, so that's chain rule. And so even though they're both f and g, we should be able to tell which is product and which is chain. Okay, so let's do chain rule for number 1. Outside's derivative times inside's derivative. Okay, so that's another trouble that students have, building chain rule correctly and being able to put it into the correct notation for chain rule. Any questions there? Okay, replace every t with 1. Yeah. That's fine. Yeah, that's fine. Okay. Now, there are multiple pieces, multiple things going on here, but you want to just kind of take things one step at a time. What feels like a manageable step that we can find? Find g of 1, right? So when you find g of 1, you're just finding the y value for the g graph at 1. And when you find that y value, you're going to replace that g of 1 with that number, but copy the rest of the problem down again because we haven't resolved anything else. So g of 1, you look at the g graph. The g graph at 1 is, g of 1 is 1, here. And then once we replace g of 1 with 1, then recopy the rest of the problem. And now you're just left with two things left to find, f prime of 1 and g prime of 1. And these are asking for the slope of the f graph at 1 and the slope of the g graph at 1. So one thing is confusing about this is asking for the slope of f graph at 1, right? But this is not very clear, I know, sorry. So f graph, the slope here, if you look to the left, it looks like a slope of 2. To the right, it looks more like a slope of 1. So it's not clear. But on the test, I'll make it a straight line so that you're not having to guess. But even if you chose between either 2 or 1, I would give credit to both versions of that slope because there's that ambiguity there. But either way, you're just finding the slope of what you can do at that point with your f graph, and then the slope of the g graph at 1 is going to be a negative. This is clearly negative 1, right? So 1, or you can do 2 times negative 1 or 1 times negative 1. So you're either getting negative 1 or negative 2, depending on how you interpret the slope here at that point. So as far as function notation problems on the test, chain rule is the one that gives students the most trouble. All right, number 2, we use what rule? Product rule. Okay, so build your derivative using product rule. Three, and then use the graph to help you pull the numeric values, either slope or y values.
Would it be okay if like after we wrote the equation, if we just plug in all of them? Like if we just write like a c prime of t equals f prime of t times g of t. We just go straight to like c prime of 3.
That's fine. I just want to see some resemblance of you. I just want to see that you're using and then that's fine. Page 26 is something that we've practiced already today, which is finding the derivative using quotient rule and then implicit, power rule, product rule. So we'll come back to these problems if we have time, but I'd like for us to do some more practice with particle motion. So you can turn to page 27. Okay, with 1 and 2 here. Your keys are attached. Always look at the key. All right, page 27. Particle motion. So part A is already talking when the particle moves. So if you look, the first job was your velocity sign line, right? So get your velocity function, set velocity equal to 0, find your critical numbers, calculate your velocity sign line, find your signs for each interval, and then that's going to help us answer a lot of the questions. That I know, like just have that space there. For these purposes, I'm also finding when the particles move to the right.
and the same size.
So. Yes. So I found acceleration, which is 16 minus 18. A of 2 is negative. B of 2 is also negative. So because they are both negative, same signs indicate speed is increasing. Okay, what's the definition for average acceleration? Good, change in velocity over the change in time. We know it's going to be units per second squared. Also, if no units are provided in the problem, then you don't provide unit, but I think on the test, I'll have either like meters or feet or something, but we know it's always going to be something per time squared. See, zero equals 1 and t equals 5, so just find the location at these moments of time. So here are the new things that you're going to see on the test that wasn't on the quiz, and that's displacement and distance. So displacement is defined position minus initial position. We want to find x of 3, which is doing final minus initial. It's okay to get a negative number for displacement. It means you end up to the left of where you started. or meters.
Whatever the units are for the test.
Distance, we also are going to use largely the same data as displacement, but we may need an additional location depending if there's a change in direction that the particle experiences. So we still want to use the starting location and the ending location, but we may use there would not be any additional information needed if there's a change in direction. We only care about change in direction between 0 and 3. Where? That's not mine, right? There is a change in direction. If there's no change, this is all data we need, but we is where the particle is at 1 t into the position function. In this case, I get 10. Okay. All right. So we're adding a bunch of. Probably not going to get you the right answer. So think in terms of you're walking between these locations on the number line, and then you're just counting your steps as you go. Okay, so you're starting at 3 on the number line, and you're walking to 10, and then you're walking back to -6. So from 3 to 10, you're going to count your steps, and then from 10 to -6, you're going to count your steps. And whatever you get is your total distance. So from 3 to 10, how many steps? 7. From 10 to -6, how many steps? 16. So how many steps have you taken? 23. That is your total distance.
For the test, you must do attention here if we have it.
Yeah, I will have units for you on the test. So, and I'll ask you for the units. So you attach them. It could be feet, it could be meters, okay, centimeters, whatever. The displacement. The only time you use velocity is just to check to see if there's a change in direction. But other than that, you're not using the velocity function per se. Increasing. It's not talking. It's talking about the slope of velocity, right? Which is just acceleration. So if acceleration is positive, then I'm getting a positive slope for my velocity. If it's a slope for my velocity. Find what a of 2 is. And velocity separately. the test tomorrow. Any questions? Okay, number 6. This is also a problem that requires a combination of multiple rules. Can you identify what rule is required? Product and chain. Which one comes first? Product, right? This is not over the entire thing, so we know it's going to be the other rule, because the other rule is going to have a wider impact. So you want to choose the rule that sees a bigger portion of the problem first. So you look at the parentheses. So product first, and once we're inside product and chain, will show up. If you did chain before product, I guess you could do chain just to get information, but a chain before product, it won't give the right answer. A chain before product will look more like this. This is more of a chain before product. So you do product, so you do chain rule first, and then once you're inside. I know right now we can avoid product because we just expanded and use power rule, but for now, this is what a chain. The chain for product here, it won't get the right answer. We multiply, so I can put my stuff together. 4 and 3 can combine. I can multiply the variables together by adding exponents. 2 plus 1/2 is the same thing as 4 over 2 plus 1 over 2, which is 5 over 2. Thing, let's do page 26. Let's do the implicit problem on number 3 here. Yeah. So here the fraction, I just put the numerator to the 4th up here, the 2's in the denominator, and I push that variable back down here. Here, all these are being multiplied, so I'm just combining terms together. So the 4 and 3 can come together to be 12. The x to the 1/2 and x squared can come together to be x to the 5/2, and then the parentheses.
Oh, okay. Thank you.
3 on page 26. I'll zoom in on this one here. Great. Y cubed plus 6x squared y minus 12x squared plus 6y equals 1. So what process is required to find the derivative here? So implicit and yeah, product is within that 6x squared. Y. Derivative to ultimately what you're showing there. So page 30 and 32 tonight as a final preparation for your test. If you feel good about those 3 pages, tomorrow's.
Thank you, Mr.
Thank you guys.